So guys, now we will look into certain examples. These examples will be having both the situation that I have described before in this video. There will be projectile motion and also motion in a circular path. Okay, so let's first go ahead and let's look at the first example, a question that we can generally receive regarding an object's motion as a projectile. Okay, let's say in a question you're given a particle or an object of mass m kilograms. So the mass is m kilograms, or let's make it more specific. It was given a mass as 1 kilogram. So the downward force acting on the object is m1g. So I can write it as g newtons right here. Okay. Then they say that there is a northerly force acting on it. So let me break a misconception. Some people think that this is north, this is south, and then this is east and west. Okay, this is completely wrong. Okay, north, south, east, and west always are in the horizontal xy plane. So the question says that there is a northerly force of 2 newtons. I will say that that force is acting along the positive y-axis. That is 2 newtons. Okay. This is of 2 newtons, and the particle is on the ground, so there is no initial height. The particle is thrown from the ground. Okay, so now let's draw the axes. This is the x-axis, we have it here. This is the y-axis, okay, and this is the z-axis. This, remember, this is the positive direction. Here we have the positive direction. We should always mark the positive direction. Okay, it's very important for this type of questions. It's the positive direction. Okay, now the particle moves in this way. Okay, this is the range, and this is the maximum altitude. Okay, and this is the range of the particle. The initial speed of the particle is given by v naught. So we have here our v naught is 200 meters per second. Perfect. And then we have the angle of elevation, that is pi upon 6. This is our angle of elevation. So we have here our theta is pi upon 6 radians. Perfect. Okay, now let's go ahead and let's start from here. We said that F is equal to ma, so let's write that F is equal to ma according to Newton's second law of motion. F is a vector, so here what is our F? F will be, we have it here, g. So there is no F in the I component, there will be 0 I, okay, in the J component. Okay, now let's check that. Now let's check in the J component. In the J component, it's positive 2, so 2J. And then in the K component, it's negative G, because you see G is acting downwards, while we consider the positive direction to be upwards. So in the K component, it is negative G. It's negative G. Okay, so negative G, and then that will be the K component, as I told you before, will be MA. So what is M? M is actually 1 kilogram, so it will be left with us with A. Okay, so this is our acceleration vector. Our acceleration vector is given by A is equal to 2J minus GK. Okay, 2J minus GK. Now we need to integrate this to find the velocity vector. So we will integrate the acceleration vector to find the velocity vector. So what is the integration? It will be 2TJ minus GTK. Now remember guys, when you integrate, obviously you'll have an integration constant, and let's name this constant plus C1. And this is a constant vector. Whenever you're integrating vectors, you end up with a constant vector. So our velocity vector will be given by v is equal to 2tj minus gtk plus c1. Okay, perfect. Now we have something very interesting here. So listen, I told you the particle is thrown with an initial speed of 200 meters per second. So this is 200 meters per second. Okay, I also told you the angle of elevation of the particle is pi upon 6 radians. So the angle of elevation is pi upon 6. Now remember, this will have two different components. We will have a vertical component, which is given by this, the vertical component, which will be 200 sine pi upon 6. And we will have the horizontal component, which will be acting in the I direction. So it will be 200 cos pi upon 6. Okay, now remember, this particular part is the I component. It's acting in the horizontal direction. This is in the vertical component. So this is acting in the K direction, not in the J. Remember, this is K direction. Okay, now let's go ahead with our derivation. When we go ahead with our derivation of the velocity vector, we still don't have it completely. So we can write it as our V naught as a vector will give us, when t is equal to 0, V naught, we will have 200 into cos pi upon 6 I component plus 200 and sine pi upon 6 as the K component. Remember guys, this is the K component, okay? So we have it as the K component. Now let's go ahead and I'll use the calculator. I'm not a wizard. I mean, some people are maths wizard. They actually can tell this straight up ahead. I'll be straight up with you. I cannot do that. So I'll use the calculator and I'll say that sine pi upon 6 into 200 and will be, and then we will have, okay. So we have pi upon 6 right here. So when you have 200 into cos of pi of 6, you will have V naught is equal to 100 square root 3i plus, and then we know that sine pi upon 6 is 1 upon 2, and multiply by 200, we will get 100k plus 100k. So this is our initial velocity vector. Remember, we're always concerned with vector in these cases. So now let's go ahead and let's put this information in this equation. So how we will put this in this equation? We will have 100 square root of 3i plus 100k is equal to, so t will be 0, so this will be 0, this term will go to 0, and we left with c1. So this is a vector c1. So now let me remove everything else and I will start from here again. Okay, so the velocity vector can be given by, the velocity vector is given by 100 square root 3i. Now let's check the j components. What are the j components? Plus 2tj. And then we will have plus 100k plus 100 minus gtk. Okay, this is our velocity component. So sorry guys, let me just switch off my notifications. I think you'll be hearing a lot of notifications. Sorry for that. So let's go ahead, and we need the position vector. Now we have the complete velocity vector. Now I will go ahead and I'll find the position vector. So the position vector is actually the integration of the velocity vector. So we can write this as r, the position vector r. If you integrate this, it will become 100 square root 3ti plus 2t. If you integrate 2t, it will become t square j plus, and if you integrate this term, it will be 100 t minus gt square upon 2 k. And then obviously we will have a constant vector c2. We do not know what is c2. Now we know that initially, let me remove these parts since we have already worked with them before. Now we know that initially, the particle is at the origin. As I told you, there is no additional height. There is no h naught or h as we have seen in the general situation. So the position in the very beginning will be 0, I plus 0 plus 0j. I can say plus 0k. So because there is no position in anywhere, and if you see t, it will be 0, right? Plus c2. T will be 0, so this term will go to 0, this term will go to 0, this term will go to 0, this term will also go to 0. We will be left with c2. So c2 is a 0 vector. So the position vector is given to us by r is equal to 100 square root 3ti plus t square j plus 100 t minus gt square upon 2k. Now in the question they were asking us find the position of the particle or find the range of the particles. Okay, so this is the range, the horizontal distance traveled by the particle. When does the particle travel a particular horizontal distance? It happens when the position vector, the vertical position vector is 0. Got me? So when the vertical position vector is 0, so that's when the particle has achieved the range. So let's say 100t minus gt square over 2 is equal to 0. We can write that as gt square over 2 is equal to 100 minus 100 t is equal to 0. So using the quadratic formula, I can actually solve for t. So t will be equal to, but this t is specific t, this is the t for range. The time taken for the particle to reach the range. T will be equal to, we have negative b, which will be 100 plus minus b square, so 100 square, minus 4ac. So a is 0. Okay, perfect. So we have a as 0. C as 0. So there will be no 4ac terms. We can ignore that. Okay, over 2a over 2g. Notice we will be getting a positive term and a negative term, but I told you we will only take the positive term because time cannot be negative. So if I put this into the equation, so I will be having a will be 9.8. By the way, you can do this directly in your calculators also, guys. 9.8 divided by 2. B will be negative 100 and C will be 0. So one time we are getting is 0. One of the times we are getting is 0. The other time we are getting is 20.41 seconds. 20.41 seconds. Okay, but why we are getting one of the time is 0, not negative? Because the particle is starting from the origin. So that time is 0. We will take this value of tr, okay, and we will input it into the horizontal component of the position vector. So the range is given by, the range will be given by 100 into square root of 3 into 20.41 seconds. So r is equal to, so let me just calculate this quickly, 100 into square root of 3 into 20.41. We will be getting, the range is 3,535 meters. Perfect. So this is our range. Now let's go ahead and let's solve for the maximum altitude that can be reached by this particle. Okay, guys. So I hope this is getting clearer for you. I mean, in your exam or in your assignment, you may not get exactly the situation, but I'm just trying to help you build your concept, okay? So now let's go ahead and let's see our maximum altitude. So when does the maximum altitude happen? The maximum altitude happens when the particles is having a vertical velocity of 0. When the vertical velocity stops increasing, it's having a vertical velocity of 0. So we will have 100 if minus gt is equal to 0. So gt is equal to 100, okay? T is equal to 100 over g seconds. That's when the particle reaches the maximum altitude. The maximum altitude is also reached by the particle when the particle is and it's the maximum altitude is actually represented by the particle's positions vectors k component. So the maximum altitude, the A max, will be given by 100 into this t right here. So it will be 100 over g minus gt square 100 over square over 2. So we will have the maximum altitude can be given by 100 9.8 into 100 minus 9.8 over 2 into 100 square over 9.8 square, and we will be left with 510 meters. Got me? So perfect, man. This is we have solved it. We have solved a particle moving in 3 dimensions. Now we will go ahead and we will look at another example of a particle moving in 3 dimensions, but with a little bit of trick involved. The question will be a little bit tricky, but not actually tricky. So let's see what that question is. So guys, our next question is a little bit confusing or maybe tricky. It says that this particle moves pause. So our next, our next question is maybe a little bit confusing. It says that this particle moves in the xy plane. It moves in the, no, let's make it a little bit more interesting, in the y is equal to 2x plane. Oh, okay. Now let's see how we can do this. This is a very interesting problem actually, because y is equal to 2x. First of all, you might think that, okay, y is equal to 2x is a straight line. But no, it said that it moves in the y is equal to 2x plane. So it also says that the initial height of the particle, that is h dot, is 10 meters. Okay. The initial velocity of the particle, that is v naught, is 60. Perfect. And the initial, the angle of elevation, that is theta, is equal to pi upon 3. Okay, these are the information given to us. Okay. First of all, let's see how it will look like. Okay. This is the z-axis as usual. This is our x-axis as usual. This is our y-axis as usual. Now, a very interesting thing they said. First of all, the particles start at the height 10 meters. The height is 10 meters, so it started from here. Let me write this down in black. So h naught, or h, is equal to 10 meters. Okay, it starts from here. It moves in the plane y is equal to 2x. So now the plane y is equal to 2x is actually something like this, you would say. This is the plane, y is equal to, it looks something like this. Okay, now this particular plane, y is equal to 2x, the baseline, these two lines of the planes are given by the equation y is equal to 2x. Okay, the plane goes up and down infinity, like positive and negative infinity in the z-axis. That means in the k direction. Okay, the particle moves in this plane. Okay, now this is a very interesting thing that we have. Okay, perfect. Now let's go ahead and let's start analyzing this particular movement of the particle. This particular movement of the particle, we can say that because the only downward force acting on the particle is due to gravity, we can say that F is equal to ma. Perfect. We can also say that ma is negative mg k. Negative mg k. Remember, y cannot say j because this is the j, this is I, and this is k. So vertically, it's negative mg k. Okay, perfect. M and m can get cancelled. We will have left with a is equal to negative gk. Perfect. Okay, good stuff till now. Everything clear? Okay, if you guys have taken the notes, I can move forward and we can say let's integrate the acceleration vector. If we integrate the acceleration vector, we are supposed to get the velocity vector as explained in the general situation and the previous questions. So the velocity vector is given by negative gt in the k component plus a constant vector c1. Now this will be a little bit tricky. Okay, let's go ahead and let's draw this part here. So we know that the particle's velocity is 60. Okay, in here it's 60 right there. Its initial velocity is 60 meters per second. Okay, now this velocity is having a component which is parallel to the y is equal to 2x plane and a component which is parallel to the z-axis. Okay, so two components. So this is the component, I would say. This is the component, sorry. This component is parallel to the z-axis, and this component, the horizontal component, is parallel to the y is equal to 2x plane. So this particular component, as I told, angle of elevation is pi upon 3. So it will be 60 cos pi upon 3. Okay, and this will be This will be 60 sine pi upon 3. Now there's a problem here. This component of 60 is not on either the I or the j axis. It's on the line y is equal to 2x. It's on the plane y is equal to 2x. Okay, so now this particular thing, this particular velocity will have a component in the j direction and will have a component in the x direction. So now let us draw the triangle represented by the y is equal to 2x. So this is 60 cos pi upon 3. We have here 60 cos pi upon 3. Okay. We have an angle that we do not know here. In fact, we know this angle. In fact, we know this angle very well. Alpha. How? If x is equal to 2x, if x is equal to x, okay, x is equal to x, y is equal to 2x, or x is equal to 1, y is equal to 2. So x is equal to 1, y is equal to 2. Okay, so alpha will be, so this angle alpha will be tan inverse of 2. So for the initial velocity, we can write this down as, so let me write down this velocity vector on the top. So the velocity vector initially, not the initially, sorry, the general velocity vector is given by negative gtk plus c1. Okay? Now, as I told you, let's repeat, let's go through the steps again. The initial velocity, okay, 60 meters per second, is acting in the direction of the plane y is equal to 2x, so in this plane. Okay? So now this velocity will make one component, as I mentioned here, this one. So this particular component will be perpendicular to the, parallel to the k component, will be parallel to the k axis or the z axis. So it will be 60 sine pi upon 3 k. Okay? Now, the horizontal components of the velocity, okay, this one. This component actually has further two more components. One component will be in the I direction and one component will be in the j direction. The component in the I direction and the j directions can be found out by drawing a triangle. See, this is a triangle that can be made from this y is equal to 2x plane. The plane y is equal to 2x, let's assume, makes an angle of alpha, that I have written down there, makes an angle of alpha, this is the angle of theta, makes an angle of alpha with the y-axis. So we can say that the 60 cos pi upon 3 will make plus 60 cos pi upon 3 cos, and then this alpha can be found by giving x is equal to 1, y is equal to 2, and then using trigonometry we can find that alpha is tan inverse of 2, so tan inverse of 2, so cos of tan inverse of 2, this will be our, so guys, this will be our I component, and the j component of the initial velocity can be given by, the j component can be given by 60 sine pi upon 3. Okay, sorry, still sorry guys, it will be 60 cos pi upon 3, sorry about that, 60 cos pi upon 3, and then sine of, because this is the j component right here, sine of tan inverse of 2. Okay, let's simplify the initial velocity vector and let's write it down here, guys. So let's see, and by the way guys, this entire thing is the I component. Okay, this entire thing is the J component. I wrote down there. Okay, so the velocity vector in the I component will be 60 into cos pi upon 3, and then we will have cos tan inverse of 2. We will have let's take 13.416 in the I component. Okay, let's see what is in the J component. The J component will be the same. I'll just change the cos to sine. We'll have sine. We'll have 26.833 plus 26.833 in the J component. And the K component will be very simple. The K component will be plus 30 square root 3. Okay. So now if we use this information and if we have this particular velocity vector information, we can remove these. Hope you guys have written them down. Okay. Okay guys, I'll write the initial velocity here. So let's write down this information. The initial velocity is given by 13.416 I plus 26.833 J plus 30 square root 3K is equal to, this term will go to 0 because at initially t is 0 is equal to C1. Okay, now this gives us the final velocity vector that we need. So the final velocity vector is, I can just remove C1 from here. I can C1, let's write C1 and I'll write it down here again. So the final velocity vector is given by 13.416 I plus 26.833 J plus 30 square root 3 and then minus GT. Okay, this is our final velocity vector. So now let me remove everything and I'll write this on the top so we can analyze this thing, and I'll remove these things also. We can go ahead from there. So the final velocity vector is given by V is equal to 13.416 I plus 26.833 J and then plus 30 square root 3 minus GTK. Okay, perfect. Now let me remove everything and let's see how we can get the position vector. The position vector, simply, again, integrating this particular thing, we will have position vector is equal to 13.416 T I plus 26.833 T plus 26.833 T J plus, we will have 30 square root of 3T minus GT square over 2K, GT square over 2, and that's the K vector, and then we'll have the initial, we'll have our position vector constant, so that will be C2. Now we all know that initially the position vector was at 10K, so C2 will be 10K. C2 is 10k. Okay, so now our position vector is updated to So our position vector is actually updated to 13.416 Ti plus 26.833 Tj plus 10 plus 30 square root of 3t minus gt square over 2k. Okay. Now the question is asking find the position vector and also find the position vector and find the time at which the particle hits the ground. So to do that, the k component of the position vector will be 0 when the particle hits the ground. So we will be having this equation. Let's write the k component, but I'll just reverse every sign. So I'll be having gt square upon 2 minus 30 square root of 3t minus 10 is equal to 0. So guys, I hope you know the quadratic formula. I'll get two values of t. You can also directly use the calculator. In your calculator, you will have 9.8 divided by 2 minus 30 square root 3 as your value of b, and your value of c will be negative 10. So one of your values of k will be negative 0.18. Ignore that, time cannot be negative, but the other value of t will be 10.793. 10.793 seconds. This is the range. This is when the particle will impact the ground. Okay, now let's take this particular time. Okay, let's take t is equal to 7.93, 10.793, and let's put it in this particular place. So this will be when we substitute t is equal to 10.793 in these places, we will get the position vector of the particle as it impacts the ground. So it will be r is equal to, when r of impact is equal to 13.416 into 10.793, as I said. Yes, I'm correct. 10.793 I plus 26.833 into 10.793, okay, kj. Okay guys, why I don't need to input it here? Because if I input it here, it will give me 0. And it makes sense to give me 0 because it's on the ground. There is no height, elevation, so k will be 0. So I'll be having the position vector of the impact as asked by the question is 13.416 into 10.793. This will give me 145. Let's take 145 in the I component, and then I have 290, okay, plus 290 in the j component. This is the position vector of the particle on impact, okay? And you can obviously take the magnitude of this to find the range of the particle on impact. Or if you just want to find the range of the particle on impact, you can just put the t value on the horizontal component. And in this case, no. Why you cannot put it on the horizontal component? Because you have y is equal to 2x. So you have to find the magnitude, okay? Got me? Okay, guys. Now let's move ahead to a question with circular motion. Start from now. So, guys, now we have a question in which it says that in a roller coaster. So this is a roller coaster. Okay. In this roller coaster, it's going in a circular loop. The radius of the circular loop is given by 100 feet. Okay, Okay, now they're asking us something. They're asking us what is the angular speed of the roller coaster such that the roller coaster will feel weightlessness on the top. So the roller coaster feels weightlessness on the top. So what does this mean? This means that the centripetal force is actually the weight. Okay, the weight or the acceleration is the centripetal acceleration is actually the acceleration due to gravity. So whenever the roller coaster is feeling weightlessness, that means the acceleration is due to the acceleration of gravity. Okay, the centripetal acceleration is the acceleration of gravity. So the position vector from this question, we can write the position vector is given by 100 cos. So the position vector is given by 100 cos Wt plus 100 sine Wt. Okay, guys? So now let's go ahead and let's find the velocity vector. The velocity vector will just differentiate the position vector. We'll get out the velocity vector. The velocity vector is, so it will be minus 100 W, which is the angular speed which we need to find, sine of Wt plus 100 W cos of Wt. Okay, guys? Now let's find the magnitude of the velocity vector. Okay? The magnitude of the velocity vector is given by, we'll take the square root. Okay? As we take the square root, it will be negative 100 W sine Wt square plus 100 W cos Wt. Okay, and then we'll have the entire thing as square. So we're taking the magnitude, okay? We will have here, we can simplify this as 100 square, because negative 100 square or 100 square is the same thing, so we can take 100 square as common. We can take omega square as common, okay? And we will be left with sine square omega t plus cos square omega t. So this particular velocity vector, the magnitude of the velocity will be given by, so this thing is actually 1. Okay, we will left with 100 square and omega square. And square root of 100 square omega square is 100 omega. Okay, so the magnitude of the velocity is 100 omega. Got it, guys? Perfect. Okay, now let's find the, I'll remove this. Let's find the acceleration vector. So let's see, what does the acceleration vector say? The acceleration vector is given by, you have the acceleration vector, you differentiate it again. So it will be negative 100 omega squared cos omega t. Okay? And then you will be remaining with negative 100 omega square sine. Okay, guys, I'm very sorry for that. I mistook something. This will be the I component, and this will be the j component. Again, here I component plus the j component. So this will be the I, and then the j component will be 100 omega square sine omega t, will be negative right here, and then it will be the j component. So if you take the negative 100 omega squared as common outside, so we will have it here negative 100 omega squared as common, and we'll be left with cos of omega t as the I component minus or plus sine of omega t as the j component. When we take the magnitude of the acceleration vector, we are left with acceleration vector is equal to negative 100 omega squared. This is the magnitude. Okay? So why is that? I will tell you. Why is that C? When I take the magnitude, I'll be only concerned with this part. The constant, leave it outside. So what will happen is, it will be positive, okay? Because you take the magnitude, okay? So what will happen is, cos square omega t plus sine square omega t will be 1. Multiplied by the magnitude of 100 omega square, which is a constant, will be remaining with positive 100 omega square. Pause. So, guys, I told you that acceleration is only due to gravity because they're experiencing weightlessness. So it will be 32 feet per second because I told 100 feet. So 32 feet per second square will be equal to 100 omega square. Okay, so omega will be the square root of 32 over 100. Okay, now what did I tell you V is? Velocity is 100 into omega. So we found the value of omega, which is given by 32 over square root of 32 over 100. So the velocity of the roller coaster throughout the ride is 100 into 32 square root of 32 over 100. So it will be 40 square root 2 or 56.57 feet per second. 56.57 feet per second. So guys, this is how you would solve a question, a type of question in circular motion. Of a roller coaster, sometimes it can be of a person swinging something, sometimes it can be of a pendulum. It really does not matter. All you need to learn is how to get to the logical derivation of the position, velocity, and the acceleration vector. Then everything gets easy. But remember one thing, guys, when the riders are feeling weightlessness on the top, the acceleration is only due to gravity. There is no other acceleration here. Okay, guys, thank you for watching this video. Hope you enjoyed. If you have any questions, please put them down in the comment section. And yes, if you have any more questions or suggestions that I need to take care of, put them in the comment section and I will be happy to answer them or address them in my next video. And please subscribe to my channel to get more math videos for college class. Thank you, guys. Thank you very much.